Hello guys, welcome to the channel. In this particular video, I have explained the problem smaller sum. So let's get started. Okay, so here is the problem statement and it says that you are given an array ARR of n integers. For each index I, you have to find the sum of all the integers present in the array with a value less than array of I. Okay, so let me explain the problem with this particular example. The problem says that we are given an array of size n. Now for each element in the array, we need to return the sum of all the element which are smaller than the current element. Okay, so for the first element which is 1, you can see that there is no any element which is smaller than 1. So the sum is going to be 0 here. Now what about this 2? For this 2, you can notice that there is one element which is smaller than 2. So the sum will be 1 here. Okay, now for this 3, there are two elements which are smaller, which is 1 and 2. So the sum is going to be 3 here. Now you can notice here that the output is 0, 1, 3. Okay, so let me take one more example. Let's say we have n equals to 4 and the array is 1, 4, 3 and 5. Now for this array, I'll start with the first element. So for the first element, there is no any value which is smaller than this. So output will be 2. What about this 4? For this 4, you can see that there are two elements which are smaller. So the sum of these two elements is going to be 4. Now let's come to this 3. For this 3, you can see that there is only one element which is smaller than 3. So the output will be 1 for this. And for this 5, all the elements are smaller than 5. So the sum of all these elements is going to be 8. So you can see that 0, 4, 1, 8 is going to be the output for this particular test case. Now I hope you have understood the problem well. So let's talk about the solution. Okay, so in order to explain the solution, I'm going to take the same example, which is n equals to 4 and array equals to 1, 4, 3 and 5. Now the first approach that comes to my mind is for every element in the array, we can iterate over all the elements and we can count like we can find the sum of all the elements which are smaller than the current element. So we just need to check one condition, that if the element, let's say, okay, so let me even write the pseudocode that we have. So for I equals to 0, okay, so let me write using the text here. I'm just going to do one thing, but before that let me remove this stuff as well. Okay, so now I just need to write the basic idea behind the code that we have. This is the first approach. So I equals to 0, I smaller than n, I plus plus. Okay, now inside this I'm just going to check run one more loop again, which is j equals to 0, j smaller than n and j plus plus. Inside this loop I'm going to check only one condition, and that condition is if the current element is smaller than array of I. So if array of j, which is the current element, is smaller than array of I, in that case we have got one element which is smaller than the current element array of I, right? So we need to increase the sum, because we at the end we need to return all the like the sum of all the elements, right? So I can do something like this. Okay, now at the last, when the j loop completes, then I will have the sum of all the elements which are smaller than equal to array of I. So I just need to store the answer in the list. So, and at the end we just need to return answer list. Okay, so let me tell you what is this answer list. So you can see that the output is basically of a list here. And even for this, why? Because we need to find the answer for each index I, right? So we are going to store that answer in a list. So answer will be a list which is going to store all the values. Now we need one more thing here, that whenever we start the loop, then we need to first initialize the sum as 0, because we need the answer for that particular element which is array of I, right? So this is how we can solve the problem. Okay, now what is the time complexity of this approach? First of all, you can notice one thing, that this is brute force approach. Brute force approach. Why I am saying that? Because we are just trying out all the ways blindly, right? Okay, so this is going to cause the time complexity of O of n square. Let me tell you how. This is the first loop that we have. So this is going to run O of n times. Okay, again we have one more loop which is going to run O of n time again. Okay, so now if you guys are aware of the concept of nesting of loops, then you will find that whenever we have two nested loops, then the complexities gets multiplied. So it will be O of n cross n, right? Or O of n square. Okay, so this is about the time complexity. What about the space complexity? Space complexity is going to be of n, because we need this answer list in order to return the answer, right? Okay, so this is the time complexity that we have, and you can see that the O of n square complexity is not going to work for large inputs or even large test cases. Okay, so can we optimize this? Of course we can. Let's talk about the optimal approach. Okay, so first of all, let me write the heading. So I'm going to write here uh, okay, so I have approach 2 here. Okay, now for this approach, first of all, I need to do one thing, that I'm going to draw an array. Let's say we are given an array like this, and this array is going to have elements like first of all I have 5, then I have 1, 3, 4, 6, 8, 7, and I have 2. Okay, so you can notice that I've just written the elements or the numbers from 1 to 8 in jumbled manner. Okay, so let me write the sorted manner as well. So the sorted manner will look something like 1 2 3 4 5 6 7 8. Okay, so this is basically the sorted form, and this is the given input form. So I'm going to write array here, but this is actually the input that we have. And what is the size? N is going to be 8 for this input. Okay, so we have this input, and I've just written the sorted form. So what we can do is, first of all, let me tell you one thing. Let's say I'm at this particular index I. Okay, you can notice one thing in the sorted form, that all these elements just before I, which means that element from 0 to let's call it index instead of I, index minus 1, because I need index I for this, right? Okay, so index, so element from 0 to index minus 1 are surely smaller than this 5. Why? Because this is sorted manner, right? Okay, but we can have one more condition, that uh, okay, so let me just make a simple statement here, that all the elements just before I are smaller than equal to the current element that we have. Okay, now I need to do just one thing, that for each element in the array, I just need to find the first greater or equal element in the sorted array, right? I hope this makes sense to you. What I can do is, for every element in the given array, okay, but before this I need this sorted array, right? Okay, so I can make this sorted array just by doing this. I will copy this array. So if I'm given this input, so my first step is going to be, uh, let me use black color for this. So my first step is copy input array, and after that sort the copied array. Okay, this is pretty simple, right? Okay, this is the first step. Now we have this array. Okay, so for each element in the array, I can just for each element array of I can just find the first element which is just greater than or equal to the current element. After that, I can surely say that the element just before this will be like strictly smaller than the current element that we have, right? Okay, so I can do this. Let's see how I can do this. First of all, I'm going to write we have for each element in array, let's call it array of I just need to find all the elements which are okay, so I just need to find the first index which is greater than equal, or okay, so the element at which is greater than equal to the array of I. Okay, so I will get index by performing a binary search here. This is very special. This is very special. And first of all, let me write this thing. After that, I will tell you. Sorted array I am going to pass first of all, and after that I need the array element itself. Okay, what is this? This is basically, you can see that this is the sorted array, right? And when we need to find the first element which is greater or equal to in sorted array, in that case we can make the use of binary search technique. Binary search, this is how we are going to optimize this searching here, right? We are searching all the elements here, but we can optimize it. Now let me tell you one thing, that in C++ we have this function, right? We have a function which is lower bound, which does the same task that we are going to do here, that we are going to perform using binary search. Okay, and this is about C++. What about Python? In Python as well, we have one function which is bisect left, which is bisect left. So this function is again going to do the same task, but there is no any such function for Java coders. So what I'm going to do is I'm going to provide the implementation of these function as well, so that it will get easier for you in order to understand the intuition behind the implementation. Okay, so like what goes behind the scene, this is like this. Okay, now let me complete this. So once we have this, once we have the index, I just need to do one thing. I'm going to calculate the sum from 0 to just before the index minus 1. I hope this makes sense, because I have already told you that element just before the index are all smaller than the current element array of I that we have, right? Okay, so I can store this sum in array, like in answer of I, because this is what we need to do, answer of I, and after that we can simply do this thing. Okay, at last we can simply return the answer. Okay, so this is the approach that we are going to follow, but now I have not talked about two things. The first is the binary search, how to implement this, and the second thing is what is this sum from 0 to index I minus 1. Because if I perform this sum from 0 to index minus 1, then it is again going to cause the complexity of O of n, right? Okay, but I have an optimal way to do this. Let's talk about the optimal way. It is pretty simple and straightforward that if I have the array 1 2 3 4 5 in the sorted form, this is what we have here. Okay, I can make a prefix sum array. How to make it? First of all, my prefix sum array is going to have the first element. Okay, after this I'm at this index and I need this sum, so I'm just going to pick up this element and add this element, so this way I will get 3. Okay, again I can do the same thing. I will pick this element and pick this element, the sum is going to be 6. After that I will pick this element and sum is 10 here, and you can even notice that the sum from this element to this element is going to be 10. After that, pick this element, and the sum will become 15 here, and the sum of all element will surely be 15 here. Okay, so now let me write the formula first. Here prefix of I is going to be prefix of I minus 1 plus array of I. And array of I is here the sorted array, not the array which is given as input. Okay, so this is the formula that is basically used to build the prefix sum array. And along with this, what does prefix of I means? Prefix of I at every point is going to give me the sum from 0 to I, right? You can see that if this is prefix of I, then it is giving me the sum from 0 to index I, which is this particular sum. Okay, so we can make the use of this. Since we want the sum, we can build the prefix array using the formula that I have told you. It is not a very big deal. Even you will get you will understand this thing from the code that I will show you. Okay, so here I can replace this line. But first of all, let me remove all this stuff. So I'm going to remove this. Okay, here I need to write prefix of index minus 1. But again, there's a problem. The problem is, you can see here that this is index minus 1, right? Okay, so there may be a case when we have this index as 0. So in that case, when we do 0 minus 1, then I will have minus 1 in the index, and this is not going to work. Why? Because this is not Python language where I can do array of minus 1, right? Okay, so in order to handle this, I first need to check if my index is not equal to 0. So okay, I can simply write here that if index is not equal to 0, right? Okay, but you may ask me, what is the case when index is equal to 0? So the case is, let's say I have 1 2 3. For this 1, you can see that there is no any element which is smaller than 1. So in that case, it is going to return me 0. Okay, I hope this makes sense to you. So in that case, I will have 0, and else I can simply do one thing, that answer of I is going to be 0 in that case. And it is obvious. Why? Because if there is no any element which is smaller, then in that case simply answer of the sum will be 0, right? Okay, so this is the approach that we are going to follow. Till now we are just left with one thing, which is binary search. But let's talk about the time complexity. I have O of n for this, and I have O of log n for this binary search. You can see that the total complexity in that case is going to be O of n log n. So this is how we can solve this problem, right? Okay, now let's talk about this binary search, and I want you guys to note this particular code snippet somewhere, because this is what the approach is. Okay, so let's talk about the binary search code. First of all, we need to know that what actually the binary search function is doing. So it is basically finding the element. Okay, so it is finding the element which is greater than equal to finding the element finding the first element, actually finding the first element which is greater than equal to target, right? We have some target. What is the target value here? So let me tell you about the target value. If you see this array, then you can see that I'm passing a target value as well here, right? You can see that this is the target value. We need to find the first element greater than equal to this particular value, so that's why I'm calling it target. Okay, so now let's talk about this. Let's say we have an array which contains the element which is 0 1 2 3 5 7 and after that 10. Okay, and I need to find, and this is basically the first index which is low, and the last index is basically the size of the array which is n. Okay, so I need to find in this particular search space which is low to n. Okay, so of course I'm going to traverse till this condition is true while low is smaller than high. What is high? High is basically n here, so high equals to n. Okay, now there are two possibilities for every value. There are two possibilities. What we generally do in binary search is, we first of all, the first step is to find a random index which is mid in that case. So low plus high is going to be so mid is going to be equal to low plus high by 2. This is the first mid index that we have. Okay, whenever we have mid index, then there are two possibilities. Let's say the target value for this example is, well, what is the target value that we can take? Let's say we take 10 as 9 as target value. Okay, so we need to find the first element which is greater than equal to 9. The answer should be 10 here. We already know this, but how to implement this? This is low, this is high. What is the index of low? 0, 1 2 3 4 5 6 7 8, and high is basically 8. So we are performing binary search from 0 to 8, right? Okay, what is 0 plus 8 by 2? This is the first mid element that we will have, so it will be 4, index 4, and 0 1 2 3 4. This is the first element that we have. Fine, now you can see that there are two possibilities. Either this element, array of I, array of mid, is strictly smaller than the current target that we have, target, or there is one more possibility which is covered by else condition, right? If it is greater than equal to target, and this is what we need to find, but we need to find the first element. Okay, so whenever we have such condition like this, in order to, in that case, let's say I'm at this position, right? So I need to find the first greater element, so it will be just immediate after this the smaller element. Okay, so I can move to right. In that case I can move to right because this element is smaller than 9, right? Okay, so I can, when this element is smaller than 9, this condition is true, then I can surely say that my answer will be in the right part of the array, right? We can eliminate this part. Okay, so I can simply do one thing, that my low is going to be equal to mid plus 1. Pretty simple, है ना? Alright. Okay, so after this, I can do one thing, that if my element is greater, let's say I have 11 here. Okay, so if I'm at this 11, then there may be a possibility that my answer is in the left side, right? You can see that the answer in the left side. So in that case, I need to move to left. Okay, now I want to search in this particular search space. How to do this? In that case, I need to make low to high to mid, right? I'm making high to mid. High to mid. Okay, now you can ask one question. Hey, we are making low equals to mid plus 1, but why we are not making high equals to mid? So let me tell you that in this array, the initial array that we have, we are searching in the search space which is 0 to n, right? This is low to high. Okay, so this means that from the last index I need to do last plus 1. So this is what I'm doing here. If this is the last index and I need to search in this space, then I will do last plus 1, and this will be the index that where I need to move, right? Okay, I hope this makes sense to you. And at last, I can surely say one thing, that my low will be pointing to my answer, because my low is continuously moving to the left, right? So when this loop completes, then low will be the index which will be pointing to the first index, which is greater than equal to array of I. So I need to return low. This is what we need to do. This is the whole approach that we have, right? Okay, so till now I have we have done two approaches, and the binary search function is now complete, and we have seen the main approach. So now I am going to show you the code. Okay, so on the left hand side I have the Java code, and on the right hand side I have the C++ code. Okay, so the C++ code, we have a by default function which is lower bound, right? Okay, so but still I have implemented the binary search solution here. So I have written binary search function here and here as well. Okay, now what is the main logic? I hope this makes sense to you. This is very clear because I have just explained this thing to you, right? Okay, now this is the main logic that we have. First of all, we are making the answer array. Okay, and after that we are making this index in. Okay, after that we need the prefix sum array. Why? Because we want to right, we want to get the sum for this case, right? Okay, this will be index minus 1. This will be index minus 1. Okay, now you can see that how I am calculating the prefix sum array. So this particular part is basically for calculating the prefix sum array. Okay, because I am showing you this because I have not explained in detail about the prefix sum concept. Okay, now this is the part where I am sorting the array, which is array of copy. Okay, now for the element, this is the main logic that we need to perform. We are performing the binary search, and then we got the index, and we are just checking index is not equal to 0. In that case, do index minus 1, prefix sum of index minus 1, else just increase the index. What is this? I already know that the value or the by default value in answer is 0, so I don't need to make the answer in equals to 0, but we can still do answer of in equals to 0 because this is more easy to understand for beginners. So I'm going to do index of I equals to 0, answer of I equals to 0, and same thing you can do here as well. Okay, now let me show you the Python code as well. So this is the Python code that we have. I am going to make a note here that if you write this particular implementation, then this is not going to get your solution accepted. There is a reason. The reason is we can use a bisect left function, which is the by default function which is provided by the Python module. Okay, now we are using bisect function here, bisect left function here, which is same as the function that we have implemented and the lower bound function that you have seen. Okay, now the bisect left function is implemented in the C language, right? So that's why it will be more faster than this function, and even this is the reason why the bisect left function is getting accepted. Okay, so this is all about the second approach. We have already discussed the complexity of second approach. Let me tell you in brief again. Okay, so the complexity of second approach is going to be O of log n, O of n log n. So the time complexity will be okay, so the time complexity will be O of n log n, and space complexity will be O of n here, because we are storing the answer and we are making the array copy, which is going to store the sorted manner, right? Okay, now let's talk about the third approach that we have. We have one more interesting approach, which is map based approach. So I'm going to write the heading, which is approach 3 here. Okay, so let's make it bold and underlined. Okay, now let me take the sorted array again. So I'm going to write the elements in sorted manner: 1, 2, 3, 4, 5, 6, 7, 8. Again, we know one thing, that if I'm at this particular value 5, then all the elements before 5 are surely smaller than this element 5, right? Okay, even if we have duplicate elements, in that case you can see that if I'm at this particular element 5, then all the elements before this are smaller than 5, right? But when I'm at this particular element 5, in that case all elements are not smaller than 5. We have this element which is equal to 5. We don't want this. Okay, so I will tell you how to handle this case, but in order to make it easier, let's take 5 is here. Let's take we have distinct element. Okay, so I can say that all the elements just before array of I are smaller than this particular element. Okay, we are going to make use of this. We are going to maintain a sum here. We are going to maintain a sum here, which is the prefix sum. Let's say I know the sum till now. Sum till this point is 10. Okay, so for this element 5, if I'm at this element 5, I can surely say that for element 5, all the elements which are smaller than 5 are going to have sum 10, right? Okay, and okay, so let me explain, let me do this thing for the from the starting point, and you will automatically get the intuition with this. Okay, so initially I have the sum 0. Initially I have this sum. Let's say I'm taking this sum which is 1, and I'm starting from this point. Okay, because for this element I already know one thing, that there is no any element which is smaller than this. So in that case, answer of 0 is always going to be 0. Okay, for the sorted array, not for every array that we have. Okay, so now initially the sum is 1 and I'm at this point. Okay, so at this point the sum, I know that for this element the sum of element just before this is going to be the sum of element smaller than this, so this is 1. So I can store one pair that for the element 2 the sum is 1. Okay, after that I am going to increase my sum will now become 3. For this point sum has become 3. Okay, then I come to this particular point and I can say that element before this are smaller than this 3. Okay, so I can store the sum with this value. Okay, so I have one more pair which is 3 and the value is 3 here. Okay, this means that for this element 3 in the array, the sum of all the elements smaller than element this 3 is going to be 3. Okay, after that I'm going to add these value. So now the sum has become 6 till now. Okay, after that I come to this point, and for this point I can again see that all the element on the left are smaller, and I know the sum of these elements which is 6. So I can store one more pair which is 4 and 6. Okay, after that the sum will become 10 for till this point. Okay, so now I come to this point and I can say that for 5 the sum is going to be 10. Simply means that the element just before 5 are smaller, so the sum of all the elements smaller than 5 is going to be 10. After that the sum becomes 15 till this point. So again for 6 I can say that the sum is 21. Okay, now for this 7 I can again say that the sum is going to be, what is 21, what is 21 plus 7? What is 21 plus 7? 21 plus 7 is going to be 28, right? So 28 till this point. Till this point, the sum is okay. I have made a mistake here. That for 6, the sum is going to be 15, and for 7, the sum is going to be 21, and for 8, the sum is going to be 28, right? Okay, I hope this makes sense to you. Let's see. 15 plus 15 plus 6, 21 plus 7, 27. I hope I have made correct calculations here. Okay, so now let's talk about the input array that we have. This is the sorted array that we have processed till now, right? Okay, so the input array that we have was like this. I have 5134687 Okay, so this is basically 5134687. I hope I'm writing this value correct. Let me see it. 5134687. Okay, so yes, I'm correct here. Now this is the input that we have, so this is basically array. Now I need to find the answer for each index, right? So for this 5 we know the answer for this 5 is this point, which is 10. Okay, for this 1 we again know the answer. For 1 answer is going to be 0. I have not saved it yet, but for the first element answer was 0. For this 3 the answer is 3. For this 4 the answer is 6. Okay, so now I hope you are able to understand that we are using key value pairs here, key value pairs, and we are storing key value pair in such a way that for each key I can easily get the value. And which data structure provide this facility? This is nothing but HashMap. Okay, so in the HashMap we are storing the key value pair. This is what we have figured out till now. Let me tell you one more thing that we have figured out. We have figured out one more thing, that in this sorted array we can make a map like this, right? So how we can make this, let me tell you. But first of all I'm going to make all this stuff smaller. What I'll do is I will select all this and I'm just going to make it smaller. Okay, so I'm going to store it somewhere here. Now let me tell you what we are actually doing. So for each element in the sorted array, for each element in sorted array, what we are doing is we are iterating over all the values. Okay, this is fine, and we know that all the values are small, all the values before this are smaller. So we need to maintain a prefix sum which is equal to 0 initially. Okay, and we are going to update this sum again and again, so this will be equal to element. Okay, now I can simply do one thing, that I can store in map.put, and I can put the element and this sum, right? This is what we can do. Pretty simple and pretty easy, right? This is what we have done. Okay, at the end we will have our answer array, so we can fill the answer array like this. How we can fill? I will have answer array with initially 0, and for each element, let me remove this stuff. Of course this is the input array, but I don't need this now. Okay, so I can do for like each element in the input array. Okay, so if I have current element, then I need to store the answer for current element, right? So answer of I is going to be map.get sum for current element that I have, right? This is what I can do, and at last I will have my answer, so I can just return the answer. I hope this makes sense till now. This is pretty simple and clear, but till now I have not handled one case, which is the duplicate elements, right? If I have 1 2 3 4 5 and 5, so if you see the prefix sum, then you'll find that the sum is 15 here, and for this 5, if I see the sum of all the elements which are smaller than this 5, then the sum is this, right? Sum is not 15, sum is 10 here. Okay, so in that case I need to handle this condition. If the last element, the previous element, is not equal to the current element, so if previous is not equal to current element, as this is the pseudocode, so you just don't need to worry about the actual code, because I'm going to show the actual code as well. And in this pseudocode, I'm just focusing on making your concept clear about this particular approach. Okay, so if previous element is not equal to current element, in that case I will return I will store pair. And if this is not the case, if the previous element is equal to current element like this, in that case I need to see what I'm doing here. I'm doing map.put, first of all element. After that, what is the value for this particular value? You can see that if I talk about this, then for this I will have a pair which is 5, and okay, so I will have the pair 5, and then I will have this particular element, right? And this is nothing but 10. Okay, so I can put this, I can do map.put element, and after that I can simply put map.get element. Okay, so this is what we can do. Even I don't think we need to put the value for this, but since I have solved the problem this way, that's why I'm telling you. But okay, you can try out not putting this value, and then you can tell me whether it's working or not. Okay, so this is the approach that we need to follow. I hope the approach is clear to you. Let me show you the code. So here is the code that we have for HashMap approach, and here is the C++ code that we have. Okay, you can see that I'm making a map which is unordered map for C++, HashMap for Java, and for this I'm making an answer. I'm making a copy array which is going to be a sorted array. Okay, so again I need a prefix sum, but now this is not an array, this is a variable, right? Okay, so I need to process all the elements from 1 to n. Why? Because I know for 0 index the answer is always going to be 0 in case of sorted array. Why? Because for the first element we don't have any smaller element than the first element. Okay, this is how I'm handling that particular test case for the duplicate elements. Okay, so let me check it over here as well. Okay, so now you can see that how I'm handling the duplicate element. If the element is duplicate, in that case I need to do something like this. I'm going to put the same element along with the sum. Okay, and here I don't need to write this particular. Okay, so if the element is not duplicate, in that case I can simply do something like this. Okay, now you can see here that I'm increasing the prefix sum value each time in the loop at last. Okay, so and this is what I have already explained you for each element, as I want the answer in the same order as our input array is given. So that's why I'm iterating over input array, and then I'm getting the value from map for each key that we have. Okay, fine. The C++ code is again very similar to the Java code. You can see that because the concept is going to remain same. What about this Python code? You can see that this is a Python code that we have. This is how we make the hash map, and this is basically the answer that we have, and this is the copy of array sorting the array and prefix some variable that we have initially, and we are going to iterate over all the element in the range 1 to n. Okay, so this is all about this problem, and I hope you are clear with all the approaches that I have explained you. And if you like the solution, then you can hit the like button, subscribe the channel, share the video. So this is all about this video now. Thank you.